The last slide of our previous video, we saw the standardization of a calorimeter so that we could find out for that particular calorimeter what the amount of energy is that's involved for every Celsius degree rise or fall, and reminding that the amount of water then has to be the same every time you use that particular instrument. Now, how do we use a standardized calorimeter? Well, here we go. This calorimeter we saw has an enthalpy change of 12.7 kJ for every Celsius degree rise. So we give a 45 gram sample of a fuel with a molar mass of 125, and we burn that completely and see a rise of 8.7 degrees in that calorimeter. So let's find the enthalpy of combustion of this fuel in kJ per mole. Here are our formulas. Delta H is equal to the minus heat, that negative value of the heat that is produced from the fuel, divided by the number of moles, kJ per mole. Now, in this case, we have the specific heat of the whole calorimeter, so we don't need MCAT. We just need that specific heat of the calorimeter times the temperature change, and then we'll divide by the number of moles. Now we plug in the numbers. 12.7 kilojoules per degree change is the C. We multiply that by the temperature change, which is 8.7 K, and we divide that by the number of moles, which is the 45 grams divided by the molar mass, 125 grams, or 110 kJ on the top, 0.360 moles on the bottom. There's 3 significant digits, except for the temperature change, so there's probably only 2 in the final answer. But the final answer is going to be 305, which you could round to 3.0 times 10 to the 2 kilojoules per mole. The next question we might ask is what we would call endothermic, exothermic. And we're asked to show the thermochemical diagram, in this case for the condensation of ethanol, if delta H of vaporization is 38.6 kilojoules per mole, and we're using 3.0 moles of condensing ethanol. This is the kind of thing you might see in a distillation apparatus where we generate ethanol and then it's a vapor, and then we condense it using a water condenser, for instance. Delta H of vaporization here would be the 38.6 kilojoules per mole times 3 moles, which to 3 significant digits is 116 kilojoules. The condensation process is exothermic, so delta H here is minus 116 kilojoules. We then diagram this on the next slide. Delta H minus 116 kilojoules, we see the enthalpy of the ethyl alcohol or ethanol up here. We don't know what the absolute enthalpy is, we're just looking to diagram the change. Here's the enthalpy of the ethanol liquid down here, and we know the delta H of condensation is minus 116 kilojoules. So this shows the progress of the condensation and the enthalpy of the gas and the liquid and the change. This would be a complete thermochemical diagram for this physical process of condensation.